Okay. So you guys have in front of you the fundamental trigonometric identities. This is called reciprocal identities. Identity means that they're going to be exactly the same. They're going to be equal to each other. So if you look over here, sine u. Oh, u is just like x or theta or b. It's just the angle. You can just use the u here instead. Sine u is equivalent to 1 over cosecant u. This is a reciprocal identity. We've already learned this stuff. We know that sine is the reciprocal of cosecant. So there are 6 of them sitting there. Can you fill out the other 5 from what we've already learned? There are 6 of them on your paper. Can you fill out the other 5? So cosine u is the same thing as 1 over secant u. Tangent, same thing as 1 over cotangent u. Cosecant u, same thing as 1 over sine u. Secant u, same thing as 1 over cosine u. And cotangent u, same thing as 1 over tangent u. So there may be a reason why we would need to take cosecant and replace it with 1 over sine to make life easier for us in the future. So we should know these identities. The quotient identities, tangent u, we know that that is 1 over cotangent u, but that's a reciprocal identity. There's something called a quotient identity, which tangent u, and we learned this already, is sine u over cosine u. That is a quotient identity. So knowing that, can you figure out what cotangent u is equal to? Excellent. Don't turn the page yet. So cotangent u is cosine u over sine u. There are a few more examples that I've added that were not on my notes originally when I printed them, so you're going to have to add these, and I would just put them at the bottom of the front page. These are some other things that you should know. They're not necessarily identities. It's just what happens when we multiply sine x by another sine x. That would be like if I had the sine of 30 degrees and I multiplied that by the sine of 30 degrees. What is the sine of 30 degrees? Half. And I would multiply that by half, and I get a 4th. But we're not actually doing that. We're just leaving it as sine of x because I don't know what the angle is. So if I multiply sine x times sine x, I'm not actually multiplying the angles. I'm multiplying the sines after I find them. I'm multiplying the sines at that angle. So not multiplying the angle. The way you write this is sine squared x. Whoops, that was a weird squared. Sorry about that. Sine squared x. So when you multiply them, you multiply the sines together, but it's still of the same angle, x. Now if I did tangent x, multiply that by tangent x, what would that equal? Tangent squared x. But we've already talked about tangent is the same thing as sine u over cosine u. So you could, if you needed to, which you will at some point, write this as sine squared u over cosine squared u. Those are all equivalent. And there's one more. You just can't see it yet. And then the third one, if I were to take cosine squared x and divide by cosine x, that would be the same thing as cosine x times cosine x over cosine x. I am allowed to cancel those because it's all multiplication. I am allowed to cancel those, and I would get cosine x. So you could cancel those, yeah.
On the second one, why didn't you do sine u and cosine u? Why didn't you do like sine x?
I should have done sine x. That would be just because I was looking at the example right above it. And sometimes in your assignments they'll put an x, sometimes it'll be u, and you're gonna mix them up by accident.
So can you just do t or
No, you should keep it as the same variable that's given. That was my I made a mistake. I'm having trouble with words today. Okay. Good question. So now, when you turn the page, you will see that we have Pythagorean identities. And these Pythagorean identities, there are 9 of them. This page is blank because we're going to do some work. We're going to find the 9. And then you might want to just label all 9 of them. I've given you a whole page. So please, feel free to do it with me. Don't just watch me do all the work. I want you to understand how we get all 9. So the first Pythagorean identity I have given to you. All right? Sine squared u plus cosine squared u equals what? On chapter 2, as a bonus question, and there were different tests, but on one of the tests, some of you may have tried this as a bonus question and it said like verify that it's true. And I saw a lot of people just kind of plug in stuff to try it. If u was 30 degrees, and I did sine squared of 30 plus cosine squared of 30, I'm sure that equals 1. What is sine of 30 degrees? 1/2. So this would be like 1/2 squared. And then what's a cosine of 30? Yeah. So if I square that, that would give me a 4th plus, and that would give me 3/4. You see how they're equal? So this Pythagorean identity exists. This is the first of the 9 Pythagorean identities, this one right here. So I'm giving you that. I've just showed you why it works. You don't have to show me why it works. I'm showing you now, okay? We're going to start with this and find 8 others. So how I can take this equation and manipulate it, I can change things to find 8 others. I am allowed to take this equation and subtract cosine squared u from both sides of the equation. Just remember a property that allows you to do that? Anybody remember a property?
A long time ago.
Okay, well, it's the subtraction property of equality. If you have an equal sign, you subtract the same thing from both sides. It's still equal. So when I subtract that, I get 1 minus cosine squared u. This is equivalent to the original one. They're equivalent. So this is another one of our Pythagorean identities. That's number 2. We have 2 so far. If I went up to the original again, and instead of subtracting cosine squared u, how about I subtract sine squared u from both sides of the equation? I would get cosine squared u equals 1 minus sine squared u. That is also equivalent to the original one. So this is another identity, Pythagorean identity. Number 3, 6 more. So what you're going to be doing in the future is you're going to be manipulating expressions and equations but I'm not gonna be there to tell you, ooh, try this, try subtracting from both sides. Like, I'm not gonna be able to tell you stuff like that. So we're doing that now so you have an idea of what you could possibly do in the future. So if you're just writing down what I say and not actually thinking through it and participating in your mind, you're probably not going to be very good at this. Probably. Hey. Okay, all of those are equivalent. That's still number one. I'm going to now manipulate it a different way, and I've kind of written this on your paper. We're now going to take that equation, and we're going to divide both sides by sine squared u. I'm going to divide both sides by sine squared u. I'm allowed to do that, the division property of equality, as long as I do it to both sides. I can divide by whatever I want. So if I divide everything by sine squared u, I now have a different identity. We just got to simplify some stuff. What is sine squared u divided by sine squared u? 1 plus cosine squared u divided by sine squared u. If I have cosine over sine, it's on the front page of your notes. I have cosine over sine. Except for this one's squared. So cotangent squared u. And then 1 over sine u. Oh, by the way, the middle one was a quotient identity. 1 over sine squared u is a reciprocal identity. So what is 1 over sine squared u? From the first page. Cosecant? Cosecant squared u. See how we did that? We took the original question, we manipulated it. It looks completely different, but it is equivalent to the original. This is another Pythagorean identity. That's number 4. Now I'm going to find 2 more by using the either addition or subtraction property of equality. I'm just going to move the stuff around in this equation. So I'm going to make, this one says cosecant squared u equals. I'm going to make a different equation, say cotangent squared u equals. So how am I going to make that one? I'm going to make this equation. See what? Subtract the 1 from both sides, right? So then we'll get cosecant squared u minus 1. Those are equivalent. That's number 5. So if you didn't follow what I just did, I just subtracted 1 from both sides. There's a third way that I could write this same identity over and over again. There's a third way. I can get 1 by itself. I'm going to use this original one, and I'm going to get 1 by itself. Except for I got some OCD issues, so I want the 1 on that side of the equation, but that's okay. So the 1's over there. What's this side going to say? What am I going to get rid of to get 1 over there? Pointing at it. If I subtract that cotangent squared from both sides, let's do it in a different color. If I subtract the cotangent squared from both sides, then I get cosecant squared u minus cotangent squared u equals 1. So if you ever had an equation, you know, in your spare, fun, free time, where you had cosecant squared u minus cotangent squared u, you could say, oh, I don't need all that. I can just replace that with 1. Very close. So that's number 6. We're following or not? I know it's 6th period on the blog, guys. Kind of. All right, then the seventh one. I'm going to start at the original equation again, and I'm going to manipulate it by dividing everything by cosine squared u. I'm going to take everything and divide it by cosine squared u. I'm allowed to do that. That is the division property of equality, as long as I do it to both sides of the equation. So I now have sine squared u over cosine squared u. What's sine over cosine? You have tangent squared u plus I have cosine over cosine. 1 equals 1 over cosine. Secant squared u. That's number, what are we on, 7? 7. And then for number 8 and for number 9, I'm just going to take this and move stuff around using the subtraction property of equality. So let me get it to say tangent squared u. I'm going to subtract 1 from both sides. Number 8. How else can I rearrange these so I can get number 9? I'm going to make it say equals 1. And to do that up here, if I subtracted the tangent, then I would have secant squared u minus tangent squared u equals 1. Number 9. So we're going to be manipulating expressions and equations, and I'm not going to require that you memorize all 9 of them, and if you miss any, here's all 9 of them, but not exactly in the order we just did them. But there's all 9 of them if you missed any of them. I'm not going to require that you memorize these, but I promise you're going to want to have that list handy as you do assignments, because you are going to be simplifying things, and we'll do just a couple examples before you leave today. You're going to be simplifying things, and you might have something like this. You might have that in your work somewhere, and you can just take that out and replace it with 1 because they're equal. This is really helpful to have in front of you when you do your assignments. We're going to do a couple of these, so that way if you aren't going to be here tomorrow, or if you want to work ahead because you don't want homework over the weekend, you at least know how to do some of them. And then we will finish the examples tomorrow and work on your assignment in class tomorrow. So the first, all of these, the directions are simplified. Make it as simple as possible. Get rid of multiplication, get rid of division, add stuff together if possible. Simplify it. Cotangent x multiplied by tangent x. Cotangent x, oh, by the way, there are different ways of doing this too. There are different ways of doing it. Cotangent x is the same as what? 1 over tangent x? Okay. And if I multiply that by tangent x, then I get tangent x over tangent x, which is 1. Does the tangent x cancel? Just for fun, I'm going to show you a different way of doing it, because there's not necessarily always one way. You only have to do it one way when you do your homework, but there are multiple ways of doing some of these. So for fun, here's a different way of doing the same question. I know that cotangent using the quotient identity, cotangent is cosine x over sine x, and I know that tangent is sine x over cosine x. So the sines would cancel, the cosines would cancel, and I would get 1. So there's another way of doing the same question. It's really your preference. Okay, example 2, we've got cosine squared x plus sine squared x. What does that equal? How do you know? Boom. It's one of the Pythagorean identities. It's actually the original one. Sine squared x plus cosine squared x always equals 1. So you don't even have to do anything. This is equal to 1. But you might have to use your notes if you don't remember it. You have to go look and see what's in your notes and what it could equal. Example 3. 1 minus cosine x, 1 plus cosine x. I'm going to look at that and say, okay, I've got two binomials. They're being multiplied together. I do not have anything that says 1 minus cosine x equals to something. There's nothing in our notes. So I'm just going to multiply these together. How do we multiply 2 terms by 2 terms? What was that? Yeah, the FOIL method. So we're going to go ahead and FOIL that. 1 times 1. 1 times cosine x. Negative cosine x times 1. And negative cosine x times cosine x is minus cosine squared x. So we use the FOIL method. And then from there, because these are, they're called the conjugates, they're conjugates, they're exactly the same, just one's plus, one's minus. You've done this stuff before, the middle 2 terms cancel out. They're inverses, they cancel each other out, and we get 1 minus cosine squared x. And then you look at that, those 9 properties that we came up with together, and are any of them 1 minus cosine squared x? Do not say it out loud. Give everybody the opportunity to look for themselves. Will you find it? What are we looking for? 1 minus cosine? Is what we're looking for? 1 minus cosine squared x? You see it? So what is that equivalent to? Sine squared x. Yeah, it's way more simpler than the original. We're just simplifying. Sometimes that might be confusing, like how far do I go, when do I stop? You want to just make it as simple as possible. Yeah.
I still don't see the 1 minus cosine.
I'm not going to do any more notes today. We will pick up on our notes tomorrow. Like I said, if you want more time in class to work on your assignment, you can work ahead. And if it's one that you don't know how to do, skip it, because we'll go over it tomorrow. All right, and then your homework is attached, so you could work ahead on that if you choose to. Otherwise, we do not have any homework due tomorrow.